Meteorology is the branch of science concerned with the processes and phenomena of atmospheric dynamics, especially as a means of forecasting the weather. All weather starts with the uneven heating of the Earth's surface by the sun. Presently, atmospheric science applies classical Newtonian mechanics to describe the behavior of the atmosphere, namely air motions obey Newton's laws of dynamics. It has been assumed for the past century that tornadoes and other atmospheric vortices are governed by the same equations of fluid mechanics as less intense meteorological disturbances. The extremely high energy densities apparently present in severe tornadoes have led other investigators to look for possible non-thermodynamic energy sources, particularly those involving electrical interactions in the last decade. It has been determined that using normal thermodynamics and elementary Newtonian mechanics produce a margin of error that is unacceptable. NASA has discovered that low-energy dust devils, even small ones on Earth, can produce radio noise and electrical fields greater than 10,000 volts per meter. A dust devil picks up small dirt and dust particles. As the particles whirl around, they become electrically charged through contact or frictional charging. The whirling charged particles also create a magnetic field. As energy increases and convection of warm energetic moisture-laden air carries energy aloft, strong updrafts form, causing the cloud to become electrified and a participant of the global electric circuit.
When we talk about the global electric circuit, we are describing how electricity naturally flows throughout Earth's atmosphere, down to the electricity that individual clouds produce. Clouds that produce lightning in a thunderstorm, for instance, feed electricity into the global circuit also. They're all a part of the same system. While we have known for a while that electricity exists in the atmosphere, scientists are just beginning to understand the relationships between the different events that affect it. Could the amount of electricity in the atmosphere change the way clouds and storms develop? Could cosmic rays impact atmospheric electricity and the severity of winter storms? By doing basic research and creating computer models, scientists hope to answer these kinds of questions.
In a thunderstorm, collisions among rain and snow cause different parts of the clouds to develop positive and negative electrical charges. When the strength of the electric field overcomes the insulating properties in the thundercloud, a lighting flash occurs. Most lightning occurs entirely within the cloud and is called an intra-cloud flash. All lightning produces a strong and sudden change in the storm's electric field, but the upward portion of an intracloud flash sometimes sends a surge of electrons rushing toward the upper part of the storm. Reaching speeds nearly as fast as light, these accelerated electrons give off gamma rays when their paths are deflected by air molecules. As energy and updraft strength increases and the storm dynamic moves further from equilibrium, the Newtonian fluid mechanics, Navier-Stokes, are expected to fail and no longer accurately describe the storm dynamics. It is this point where the electromagnetic Lorentz force becomes the predominant governing force. The Lorentz force is an electromagnetic force in which a magnetic field imposes a circular motion on charged particles which begin to emit radio waves. This force was proposed as a contributor to tornadogenesis over 30 years ago, but was rejected for a variety of reasons. However, several factors now call for a re-examination of the Lorentz force as a possible contributor toward tornadogenesis. These factors include new field evidence, a better understanding of tornadic parent storms, and a close evaluation of the previous objections. The Lorentz force may indeed play a significant role in tornadogenesis, and a better understanding of this force may in turn provide meteorologists with better understanding of tornadoes and tornadogenesis. The inclusion of the Lorentz force in our modern tornadogenesis theories can answer several questions inherent in other theories, such as why we observe tornado vortex signatures aloft as much as 20 minutes before tornado touchdown, what force is responsible for the initiation of the tornadic vacuum, and how can tornadoes exceed the thermodynamic speed limit. Once the convection core, also known as a chimney or vault, has become predominantly influenced by the action of the Lorentz force on charged particles, the plasma pulse generator, an extension to the tornado pulse generator located at about 18,000 feet AGL, begins emitting continuous radio waves which are easily distinguished from lightning discharge atmospheric radiation or spherex radio waves.